The universe as we know it is a lie, at least without its invisible twin. Every galaxy, every star, every planet you've ever seen owes its existence to something you can't see. Today we unveil the unseen structures of dark matter and reveal how they've secretly shaped the cosmos from the very beginning. The universe's most obvious feature is also its least understood. That's right, I'm talking about all this empty space. When you gaze up at the night sky, it's easy to be fooled into thinking you're seeing all there is. But look closer, and you'll find that what seems empty is actually a rich tapestry of invisible structures. These are the scaffolding of the universe, the framework on which everything we see is built. And surprisingly enough, they may hold the key to understanding the birth, life, and death of the cosmos itself. In today's episode, I'm going to show you around these structures, and hopefully by the end you'll understand why astronomers have become so fascinated by them. When astronomers began exploring the universe beyond our solar system in the 1930s, they quickly noticed that galaxies rotate faster than they should. This unexpected behavior suggested that something was amiss. There simply wasn't enough mass in galaxies to account for how fast stars whiz around them. At first, astronomers hypothesized that much of the mass in galaxies was in the form of exotic, as yet undiscovered particles. However, this idea didn't stick because it required a huge amount of this invisible stuff. In fact, it required 5 times more invisible mass than we can see. So this invisible twin of the universe remained hidden, at least for a while. But with time, pieces of the puzzle started to fit into place. In the 1970s, thanks to X-ray telescopes, astronomers discovered hot gas in the space between galaxies. While this helped somewhat, it wasn't enough to explain everything they were seeing. For instance, if you examine galaxy clusters closely, you notice that not only are there more galaxies in them than expected, but they tend to line up along the same plane. It's as though an invisible hand had pulled them all into a sheet. And this observation led to a breakthrough. Today, astronomers know that something invisible is holding galaxies together and guiding their motion. They call this mysterious substance dark matter. And although they can't see it directly, they know it's there because they can detect the effects it has on things they can observe. In other words, they can detect its gravitational pull. This brings me back to my earlier statement. What you see around you, all the galaxies, stars, planets, and people, all exist because of an invisible scaffold of dark matter. But exactly what does this scaffold look like, and how does it affect the universe we inhabit? There's a lot of data that tells us what dark matter looks like. Let's start with one of the most compelling pieces of evidence. As I mentioned earlier, it comes from looking at how light bends around massive objects. This effect, called gravitational lensing, arises because mass distorts space-time, and if the distortion is strong enough, it can bend light so much that it creates multiple images of whatever is behind the massive object. We've seen this happen with normal matter. For example, in 2022, the James Webb Space Telescope revealed 4 images of a highly magnified galaxy thanks to gravitational lensing. But what is really mind-blowing is that we see this happening with objects that we know have no visible mass at all. For example, in this image, you see 2 distorted arcs. One arc is clearly associated with this massive cluster of galaxies, but the other one, well, that doesn't make sense. There isn't any visible mass nearby that could be warping space-time. So astronomers concluded that the only explanation is that there must be some sort of invisible mass there. Furthermore, when they combined all the visible light coming from those arcs, it ended up perfectly aligning with the position of the galaxies in the cluster. The only conclusion, the invisible mass is spread out in exactly the same places as the galaxies, suggesting that both normal matter and dark matter clump together in the same places. We see this happening on the largest scales, too. If you were to map out the distribution of galaxies in the universe, you would notice that they're not randomly distributed. Instead, they form a vast network of filaments and sheets separated by huge voids. This structure is so immense that we have a name for it, the cosmic web. and dark matter plays a crucial role in its formation. So let's take a journey through time and see how it happens. First, after the Big Bang, the universe was filled with a hot, dense soup of particles. But as the universe expanded and cooled, those particles started to clump together under the force of gravity. Since dark matter interacts with normal matter only through gravity, it couldn't form any kind of structure on its own. Instead, it would have formed a smooth, uniform distribution. However, where there was more matter, both dark and normal, gravity would have been stronger, and so the clumps would grow faster. Over billions of years, this competition would have resulted in a cosmic structure where the dark matter formed a vast, thin web, and the normal matter collected in the filamentary structures that we see today. And just to give you an idea of scale, each filament is around 50 million light-years across and contains over 10 trillion stars. You know, just another Tuesday in the life of the universe. Let's move in a little closer now and look at the details. According to computer simulations, the cosmic web consists of dark matter filaments and tiny, roughly spherical halos. You can see both of these structures in this image. Interestingly, the dark matter halos follow a power law distribution. This means that while small halos are common, truly giant ones are quite rare. You might be wondering what all this has to do with galaxies. Well, as it turns out, the cosmic web plays a crucial role in the birth and evolution of galaxies. To understand how it does this, let's look at a single galaxy. Astronomers think that these galaxies are embedded in dark matter halos that extend far beyond the region occupied by visible stars and dust. This dark matter halo acts like an invisible gravitational well, influencing not just the motion of the stars within the galaxy, but also the motion of the galaxy itself. As galaxies move through this web of dark matter, they interact with the filaments and other halos, sometimes merging and splitting apart. In fact, astronomers believe that the interactions between galaxies and the cosmic web played a major role in triggering the star formation that gave rise to many of the galaxies we see today. It gets even crazier. In some cases, it appears that dark matter dominates the total mass of a galaxy. These galaxies are known as dark galaxies or ultra-diffuse galaxies. Astronomers currently know of about 20 of these, all of them located in the web-like regions of the cosmic microwave background. It's as though the dark matter in the web has, well, webbed together to form entire galaxies. What's more, these dark galaxies seem to form a bridge between the web and the more familiar galaxies we see around us. This suggests that dark matter is not just the scaffolding of the universe, but also plays an active role in building the galaxies we see around us. To understand how this works, let's return to those rotation curves I talked about at the start. Because of the web, the stars at the edge of a galaxy feel the gravitational pull of the larger structure, and this extra pull increases their speed. In other words, it's as though the stars are feeling the gravitational tug of a much larger, invisible mass. In fact, computer simulations suggest that the rotation curve of a galaxy is largely set by the mass of the dark matter halo it's in. However, not all galaxies are affected in the same way. Some are tightly bound and relatively small, while others are loose and sprawling. The reason for this has to do with the properties of the dark matter halos they inhabit. Tightly bound galaxies are found in dense regions of the web where the dark matter halos are small and compact. On the other hand, loosely bound galaxies reside in the voids between the filaments where the dark matter halos are much more extensive. This means that the dark matter web not only shapes individual galaxies, but also influences the interactions between them. And since these interactions play a key role in the evolution of galaxies, the dark matter web literally sculpts the universe we live in. Now, I know I've thrown a lot at you, so let's take a moment to marvel at the incredible structures I've just shown you. These are the dark matter filaments and halos that underpin our universe, the scaffolding that supports the grand tapestry of galaxies and stars. But wait, there's more. Astronomers predict that these structures should also be visible in the cosmic microwave background, the faint glow left over from the Big Bang. And wouldn't you know it, they've been spotted in the data. Tiny temperature fluctuations in the cosmic microwave background reveal the seeds of the cosmic web, showing that the large-scale structure of the universe was already taking shape in the earliest moments after the Big Bang. The cosmic web is a truly awe-inspiring structure, a silent testament to the invisible forces that shape our universe. It's a reminder that what we see is just the tip of the iceberg, and that there's a vast, intricate world of dark matter all around us. So what's next? The good news is that we don't need to wait until the end of time to learn more about the cosmic web. With powerful new telescopes and experiments, we're on the verge of a new era of discovery. Missions like Euclid and the Vera C. Rubin Observatory will scan the skies to map the positions of billions of galaxies, shedding new light on the structure of the cosmic web. Meanwhile, experiments like Lux Zeppelin will delve deep underground to search for dark matter particles, bringing us closer to understanding the nature of this elusive substance. Who knows what secrets the cosmic web holds? But one thing is certain. The more we uncover, the more we'll realize how deeply intertwined our universe's past, present, and future are. Now, I want to leave you with one final thought. What if the cosmic web is just the tip of an even bigger iceberg? What if there are structures beyond our current understanding that govern the very fabric of reality? It's a tantalizing thought, and who knows? Maybe one day we'll be brave enough to venture beyond the veil and explore them. Thanks for watching this episode. I hope you enjoyed it. If you want to support the work we do here, you can join our community by hitting the like and subscribe button. You'll be helping us make the coolest space and science videos we can. So thank you for your support, and as always, keep looking up.